In this video, we will be working through the process for creating the indoor bench project. This video consists of 8 parts. Part 1, we will be creating the front legs. Part 2, we will be creating the rear legs. Part 3, we will be creating the seat side rails. Part 4, we will be creating the seat front and rear rails as well as the backrest rails. Part 5, we will be creating the seat back. Part 6, we will be creating the armrest. Part 7, we will be creating the seat. And Part 8, we will be creating the storage. We have a variety of plans, including our multi-view drawing. We also have our indoor bench parts ID drawing. We have a rough dimension cut list, as well as a final dimension cut list. We have a drawing for the front legs. We also have a drawing for the rear legs. Additional parts include the seat side rail, as well as the seat front and rear rail. We have our backrest upper rail and our backrest lower rail. We also have our backrest slat drawing. And lastly, we have a printable armrest template. I purchased this bench off of Facebook Marketplace for $40 and thought that it would be a fun project to recreate and modify. Out of curiosity, I did a search and found this similar bench from Tractor Supply for $240. And I will make a point to note that although there is some solid material on this bench, there is also a fair amount of fake wood or engineered wood. When we initially calculated the project cost for the indoor bench, we estimated the hardwood lumber would total $107.19 if we were using oak at a cost of $3.50 per board foot. And this is with an estimate of 30.625 board feet. As I built this project, I kept track of every board that I purchased, calculated those out, and came up with a total cost of $105.36. This happens to be about $2 less than my original estimate. What I also did was save every off-cut piece that I could. So this is all my leftover lumber, and you will see that I have 3 fairly large size sections of boards that were left at the end of the project. And these boards total $20.25. So this is material that I paid for that just ends up being left at the end of the project. To save money on this project, if we begin by creating the seat, at least to the point where we have glued it up, which is step 7A through 7E, as well as creating the seat front and rear and backrest rails, which are also long pieces. If we can create these long pieces first, then we can use all of the off-cut pieces to create all our smaller pieces. This will save us money in the end and hopefully we will not be left with these large pieces of lumber at the end of our project. Taking a look at our plans, we have 2 front legs on our project. These 2 front legs are irregular in shape, and to make these we will be making a blank that is larger than the size of the leg, so we can then work that larger piece down into our leg shape. And based on our rough dimension cut list, this larger blank needs to be more than 3 5/16 inches thick by 1 3/4 inches width by 24 inches in length. So I'm going to begin by laying out several pieces that are 1 3/4 inches in width by 24 inches in length. When we get our lumber directly from the lumber yard, it measures 0.95 inches. Our objective is to create a board that has a thickness of more than 3 5/16 inches, which is more than 3.3125 inches. If I stack 4 of my boards measuring 0.95 inches, and I add those together, that gives me a thickness of 3.8 inches. This measurement is more than my 3 5/16 inch thickness measurement. However, because I do need to clean the surface of these boards for gluing, I need to make sure that there are no major defects in the lumber and that my lumber looks pretty good to begin with. And with all this being said, 4 pieces measuring 1 3/4 inch wide by 24 inches long will yield me enough lumber for 1 leg. So I need to lay out an additional 4 pieces. And with that laid out, I have enough lumber to yield me 8 pieces that are 1 3/4 inches wide by 24 inches long by 0.95 inches thick. We are in the process of creating this larger oversized blank for our front leg piece. If I take a look at my rough dimension cut list, we have a rough length of 24 inches for each of these pieces. On the miter saw, we will begin our first cut by squaring up the end of each of our boards. We are then going to measure, mark, and cut enough pieces that will yield us enough lumber for our 8 pieces that we will glue together for the front legs. It is worth noting, at this point, you do not want to follow any of the chalk lines. The chalk lines are strictly for laying out to make sure you have enough lumber. We want to remeasure and mark with a pencil that has a sharp tip so that we can be very accurate. I am then left with 4 pieces measuring 24 inches in length, which is my rough cut dimension. Width-wise, I should be able to get plenty of 1 3/4 inch pieces. Thickness, I am at 0.95, and my remaining off-cut lumber I can use later on in the project. I'm in the process of creating my oversized blank for my front leg. We will be having multiple pieces glued together, each piece measuring a width of 1 3/4 inches. Based on my lumber layout, I should be able to get 2 work pieces out of each section of lumber that I cut off of my original board. Currently, each edge has a milled edge from the lumberyard and a rough edge from the lumberyard. I need to use the joiner to clean up the milled edge, which is the better of the two edges, 1 or 2 times to make this edge true. We can then set the table saw to 1 3/4 inches, and with our good, clean, jointed edge up against the fence, we can cut our 1 3/4 inch wide pieces. Now, although we are creating a milled edge by having this piece touch the table saw blade, at this point it does not matter because we will be gluing these pieces together and cleaning them up after that process. And when finished, I have 8 pieces measuring a width of 1 3/4 inches by 24 inches in length. I am not concerned that I have milled edges on most of these pieces, as again, I will be gluing them together at a later process and cleaning that up. We are in the process of creating oversized blanks to cut our legs for the front of our project. This blank will consist of 4 pieces face glued together. We currently have 8 pieces, 4 for each leg. The face of these pieces are in pretty good condition because I selected good lumber, but we still need to clean up the faces so that we have good gluing surfaces. Our work pieces measure about 0.95 inches, and I will be marking both sides of my work pieces so I can verify each side is cleaned up. And with our machine set to 0.95 inches, we can run the first face through the machine. Our objective then is to only clean up the pencil marks. This will tell us that we have a good gluing surface. Because if you remember from the plans, we are gluing together 4 pieces. When it's glued up, it needs to be more than 3 5/16 inches thick. So when I put 4 of these together, they should measure more than 3 5/16 thick. Additionally, when 4 of these are together, I'm going to make sure that everything looks good visually and that I don't see any major problems. Very small gaps should be able to be eliminated by clamping the boards together. Large gaps might be an issue. At this point, everything looks good. My work pieces measure a length of 24 inches. They have a width of 1 3/4 inches. And when stacked together, they have a thickness of about 3 3/4 inches, which is more than my required measurement of 3 5/16 inches. We are in the process of making 2 oversized blanks for our front leg pieces. We are at the point that we need to glue our oversized pieces together. I'm going to begin by spacing my clamps about 12 inches apart. I'm going to lay this out so I can glue each of the leg pieces together, but I don't want to glue the 2 legs together. We want to spread the glue on the entire surface of each workpiece that will be glued to another workpiece, which means the 2 legs need to be separated so that we don't accidentally glue them together. When the glue is spread, we can flip up each piece and very gently clamp them together, making sure they are still in line with each other and they haven't shifted. We then want to add additional clamps between the first clamps and gently work our way down each of the clamps, snugging them together. Again, we are still checking to make sure that they don't shift around. When everything is clamped and everything looks good, we can use wet paper towel and wipe off any excess glue that has squeezed out. This then needs to be set aside for 24 hours. After 24 hours, we can remove the clamps from our front legs. And we want to inspect the front leg blanks for any possible issues that may have been caused during the glue up process. This could include gaps, boards that have shifted, or any other issues we might see. Using a glue scraper, we can scrape off any excess glue that has either dried underneath where the clamps were or that we may have missed during the initial glue up process. And the edges of those boards should feel pretty smooth, even if we have some discoloration from the clamps. Our current objective is to create a blank for our front legs. We are in the process of sizing this blank down to our finished thickness of 3 5/16 by our finished width of 1 1/2 by our finished length of 23 1/4 inches. It is near impossible to perfectly glue these boards together without them shifting just a little bit. So we need to start by joining two adjacent surfaces. This would be the 4 edges and 1 face. This will ensure that we have a perfect 90-degree angle or 2 adjacent faces that are perpendicular to each other. And I will be labeling these good so that I can remember that these are my 2 adjacent, jointed, perpendicular faces. We are in the process of creating a front leg blank. The final dimensions for our leg blank is 3 5/16 thick by 1 1/2 inches wide with a length of 23 1/4. During my joinering operation, I had labeled my adjacent faces with the word good so that I could remember on the planer which face needs to be face down as the planer knives are on top. I am currently sitting at about 1.72 inches. I need to bring this down to 1.5 inches. And we finished right at about 1.5 inches. In the other direction, my target thickness is 3.3125. Currently, I am sitting right at about 3.66 inches. And we will continue this until we reach our target measurement. Taking a look at our plans, the front, left, and right leg are both irregular in shape. We need to transfer this shape onto both of our work pieces. Now, although my workpieces are the finished thickness of 3 5/16 by the finished width of 1.5, I am still sitting at my oversized length of 24 inches. My finished length, according to my final dimension cut list, is 23 1/4, which also means that I have not yet cleaned up my ends, which are not perfect because I glued these together. Now, I have also created a template to help lay out the legs, and given that my template does not reach the end, this just tells me that I am on the right track and everything is the sizes that they should be. So to begin this layout, I am first going to square up one of the ends by taking off just a little bit, which will leave me with the maximum amount of material to work with. And I'm going to do this with both pieces. And I know my finished length needs to be 23 1/4. So I'm going to set up a stop block and make both of those cuts at 23 1/4 inches. When laying out the template, the end needs to be perfectly flush. The edge where our mortise hole location is needs to be perfectly flush, and our other end is perfectly flush. We are also sitting in the exact corner of the blank, and then we can trace that. I'm also going to trace that mortise hole location. I will verify the measurements later, but this will help me place the mortise hole to save a little time later. My other leg should be a mirror image of the first one, making sure we get everything lined up perfectly and then tracing it. With our legs laid out, we are ready to bandsaw. And for this to work, we need to make sure we are bandsawing about a 1/16 of an inch to an 1/8 of an inch away from the line. We do not want to run over the line or it will cause problems later. We want to first make a couple relief cuts, and then we can begin cutting out that profile. And with those shapes cut, we are ready to move on. The bandsawing process gave us a rough shape. Our objective is to have two front legs that are perfectly the same shape. To do this, we will be using a flush cut bit, but we need a template for that bit to ride along. The template that I previously made is going to be that guide for the router bit. To hold this down, I will be using double-sided tape, and then I'm going to very carefully reinstall the template, lining it up with my previously drawn lines, making sure that the excess material that I left when I bandsawed will be able to get cut off with the router. And we'll do that process with the other piece as well. Our objective is to have two perfectly cut legs that are near identical, aside from them being a mirror image of each other. And with my flush cut bit installed in the router, I'm going to raise the router until that bearing rides along the template rather than my workpiece. And we can then perform our cutting operation. With the routing complete for our front leg pieces, we need to remove the templates, which we have previously used double stick tape to hold down. To reduce the risk of damaging either the template or the workpiece, we're going to first clamp the workpiece in a vise, and using a razor blade, we will cut the template away from our workpiece, and we can gently lift that template off, and we then need to work off the double stick tape. And we will want to do this to the template as well. And with that complete, we have two front legs that are a mirror image of each other, cut identically the same. Taking a look at our plans, we have two mortise hole locations on our front legs. These two locations correspond with the seat front rail and seat side rail, which fit into the front leg. Taking a look at the front leg schematics, the 12 1/4 inch measurement does not actually go to the bottom of the mortise, but rather it goes to the point at which the leg angle changes. We then have 4.5 inches before we have another leg angle change. These measurements are not correlating to the mortise. If we take a look at our isometric, the mortise is actually 4 1/4 inches. Our angle change is 4.5 inches. This leaves 1/8 of an inch gap on the top and the bottom of the mortise. So rather than 12 1/4, it should actually be 12 3/8 inches to the bottom of the mortise. Additionally, I need to be aware when laying this out that my mortise hole locations are not the same size. And even though I used my template to pre-draw the mortise location, I do want to check to make sure that the measurements still line up. Now, it would have perhaps been easier to lay out these mortise hole locations prior to cutting out the shape of the leg. However, you do run the risk of losing those lines when you are flush cut routering this to size. It's not an issue because I can take a board that I have squared and I can clamp my leg to the board that I have squared, which will then allow me to verify these measurements much easier. So with this setup, I have the bottom of the leg flush with the bottom of my workpiece. I have the back edge of the leg flush with the edge of that board I have squared. I can then take my 12 3/8 inch measurement. This goes to the bottom of the mortise hole location, and I can lay that out. And with a square, I can transfer that mark up. And on the top side, transfer that line over. And we can see that my original mark was pretty close. The reason it is off probably accounts for tracing something on the inside, so it was good that we laid this out to verify our measurements. The back side of the leg, which is the side that the seat side rail connects to, has a mortise hole that measures 4 1/4 inches. The side of my leg, which will connect the seat front rail, has a 3 1/2 inch mortise. So I will transfer those measurements onto my workpiece. I can then verify my mortise width. On my plans, it identifies this as a 1/2 inch mortise. So again, my template was pretty close. And I can lay out that additional mortise location as well. So with both my mortise hole locations laid out for one of the legs, I can repeat this process with my other leg. When finished, the legs should be mirror images of each other. Currently, we have our mortise hole locations laid out and placed on both of the front leg pieces. And if we look at the plans, we can see that the depth we need to drill with the mortising machine is 1 inch. This 1 inch measurement is for both the mortise hole locations on both of these legs. And because our leg is irregular shaped, it will not sit flat in the mortising machine. So we're going to be using some small blocks to help space out the various pieces that we will be mortising. This will ensure that our workpiece is square. And with my block in place, my 1/2 inch mortising bit installed, my depth stop set, and everything looking good, I should be able to begin mortising. We can then set up the machine for our next cut. And with those mortise hole locations cut, we have 2 mirror image legs. With our mortise hole locations cut, we need to do a little bit of cleanup before we move on. If we take a look inside the mortise hole, we can see there are fragments of wood. These will interfere with the adjoining pieces and cause things not to line up properly. Clamping it in a vise, we can gently use a chisel to clean up the inside a little bit. And when we flip that, we will want to use a block to help clamp this square. And I'm also going to take just a little bit of 80 grit sandpaper and just very lightly sand the surfaces and the edges of this mortise location. And once that's cleaned up, our front legs are complete. Taking a look at our project plans, we have 2 rear legs on our project. Those rear legs are irregular in shape, and just as we did with the front legs, we will be creating an oversized blank that consists of 4 boards glued together. From this oversized blank, we can then shape down our rear legs. And if we take a look at our rough cut dimensions, those rear legs need to be a thickness of more than 3 5/16, which is the equivalent of 4 pieces stacked together, by 1 3/4 inches width by 37 inches in length. Much like we did with the front leg workpieces, we want to lay out 8 pieces 1 3/4 inches wide by 37 inches long. Although I have some material left from my front leg workpiece, I did have to grab 2 additional boards. However, one of the ends of one of the boards I grabbed has a bit of a defect area, and the other end also has a defect area. Now I need to be very careful because I need to surface a little bit off of these pieces to glue them together, but I don't want to have that defect deep enough that it's going to affect my ability to create a blank that is more than 3 5/16 thick. So these are some things I need to consider. So I think to minimize waste, I will be getting 2 of my pieces out of my remaining lumber. I will get 4 pieces out of one of my new pieces of lumber, and then I will cut off a little bit of my defect area so that I can get my remaining 2 pieces and still have a good amount of reusable waste at the end of this board. Our finished length for our rear leg is 36 3/16. We are going to cut this to an oversized measurement of 37 according to our rough cut dimension cut list. This will give us the ability to clean this up after we have glued it and still be within our specification for the final length. Now on the end of one of my boards, I do have a defect area. There is a bigger defect on the other end, so I need to lay this out with a little more precision to minimize waste. If I just cut off the entire defect area, that's a lot of material that I can't use. Rather, if I measure this out, I know I will need to joiner a bit of the edge of my board. I have 1 3/4. I have a little bit for my kerf on the table saw. I then have an additional 1 3/4, which puts me a little bit over 3.5, which means I'm not going to hit that defect area. This already becomes waste. So I should be fine with following my original process of just squaring up the end of the board and getting this workpiece out and not have an issue with this defect down the road. Now I am going to measure and mark this at 37 inches, which is my oversized length measurement. And I can make that cut, followed by all of my additional cuts. And I then have 4 pieces measuring 37 inches in length. These pieces I can get 2 1 3/4 inch wide pieces out of, totaling 8 pieces, 4 pieces per rear leg. This should be perfect. Creating my rear leg blank, I have 4 pieces that will be glued together. These 4 pieces need to have a width of 1 3/4 inches. I have previously cut 4 work pieces, which will yield me 2 1 3/4 inch pieces. That should be enough material for both of my rear legs. However, one edge of each of these boards is mill marked from the lumberyard. The other edge is rough. We need to first clean up the best edge on the joiner 1 or 2 times so that we have a true edge for the table saw. I have one workpiece that I know I want to cut off the defect area. To do this, I need to make sure that I am joining the edge opposite of that defect area. Even if that edge is my rough edge, I will just need to run that through the joiner, perhaps an extra couple times. On the table saw, we can then set our fence to 1 3/4 inches, and we always want that good, clean, jointed edge up against the fence. Now, as I cut these, I am not concerned that I am creating a mill-marked edge from the blade, because these will be glued together and cleaned up after that process. Now, this will be the true test to see if I plan this out correctly to eliminate that defect area. And I would say I planned that out pretty well. And that leaves me with my 8 pieces measuring 1 3/4 inches wide by 37 inches long. We are in the process of creating 2 blanks to get each of our 2 rear legs out of. These blanks have 4 boards that are glued together. Thus, we have 8 boards so that we can create 2 legs. I attempted to pick good, clean lumber, but there are some minor issues that we need to clean up so that we have good gluing surfaces, because we will be face gluing these together. Now, these boards range from about 0.94 to 0.96 or a little more. So I will be starting my machine at 0.95. And before I send these through, I do want to mark both sides. My goal is to only remove the pencil mark so that I can retain the maximum amount of material, because I need to glue 4 of these together and have it equal more than 3 5/16. After one pass through the machine, I can still see light pencil marks, so we will bring the machine down and make another pass. We will do this until both sides are cleaned up. After running those through the sander, my faces are looking really good. However, I do have one piece that has an area on the face that does not look very good. That is not an issue, because I'm just going to make sure to leave that facing out when I glue, because again, we are making this to an oversized measurement, so we will be planing this down and cleaning this up at a later state. I can then flip them up, and I am looking for any large gaps that could not be taken out with a clamp that might pose a problem in the gluing process. All of these look pretty good. I did also notice one piece that has a little bit of a split, I again am going to put that piece on the outside because this will be planed down at a later time. To set this up for glue, I'm going to be putting my clamps about 1 foot apart. And I do want to verify that any issue pieces are facing out. And I want each of my work pieces glued together, but I don't want the legs glued together. Our objective is to have a nice, consistent bead of glue that we can then spread around across the entire face of each workpiece. We want each of these pieces to be securely connected together, so we're going to take a little time to do a good job. We can then flip up each of the individual pieces and combine the legs together. Again, making sure that we are not gluing the actual legs together, just the individual pieces. We can snug the clamps very loosely at first, and we want to check and make sure that the pieces don't shift around, and we can adjust those as necessary. We then want to come back with clamps on the top and slowly work our way down the line, snugging each piece. We can then wipe off any excess glue that has squeezed out with a wet paper towel. We want to do this on both the top and the bottom. And we can set that aside for 24 hours. After letting that glue set up for 24 hours, we can remove all of the clamps and hang them back up. And we want to check the glue joints to see if there were any issues when we glued, or there is any issues that we need to deal with. These look like they turned out pretty good. We then want to clamp and scrape any excess glue or glue that we were not able to clean up sitting underneath the clamps. It should feel pretty smooth, and we'll do this for both sides of each leg blank. And everything is looking pretty good, so we should be able to move on. Taking a look at our final dimension cut list, our objective is to make a workpiece that is 3 5/16 thick by 1.5 inches in width by 36 3/16 inches in length. And because we glued up multiple pieces, we have an uneven surface along the edges of our workpiece. So we need to use the joiner to create 2 adjacent sides that are perfectly 90 degrees or perfectly perpendicular to each other. And to keep myself from getting confused, I will label my good adjacent sides before performing this operation with my other leg blank. And with that finished, I have 2 adjacent edges that are perfectly 90 degrees to each other. They are cleaned up and true. The final dimensions for my rear leg blank measure 3 5/16 by 1.5 inches. Currently, I am at about 1.7 by about 3.64. So I am well over the measurement that I need. And following the same procedures that we used when making the front leg pieces, we're going to bring these down to size. It is worth noting that you want to make sure that the good face is face down, because the knives are on the top of the machine. We have previously trued those two adjacent sides. We want to cut the opposite side parallel to our good true side. So that good side that we labeled is going to be face down. And then for the very last pass, I'm going to flip it and run that good side to clean up the side that I put the pencil marks on. And we are now sized down to our finished thickness of 3 5/16 by our finished width of 1 1/2. Similar to our front legs, our rear legs have an irregular shape. And much like the front legs, I have created a template for the rear legs. And again, like the front legs, we have left this to a oversized length measurement, so our template will not reach the full distance. So we are going to miter saw this down to a finished length of 36 3/16. First, squaring up one end by taking off as little as possible, then setting up a stop block to our 36 3/16 measurement and completing that second cut. We can then set our template on our workpiece. The ends as well as the corners should line up perfectly, as well as the back side should be perfectly flush. We can then trace around our template, making sure nothing shifts around on us. And we'll do this with both rear leg pieces. And when I laid out the template, I also traced the mortise hole location. And with both of those traced, I have 2 mirror image drawings. Taking a look at my schematic, I have several mortise hole locations. If we lay them out at this stage, I think it will be a little bit easier compared to what we did with the front legs. Now, although I did trace these from the template, I do want to verify all of those measurements. And just like the front leg, this 12.25 measurement is not to the mortise, it's to the angle change in the leg. We want to add 1/8 of an inch, just like we did with the front leg, which gives us 12 3/8. And we have a length of 3 1/2 inches for this location. And then we can verify that they are centered because this is a 1/2 inch mortise. And we can then transfer that 12 3/8 inch line around to the back side. And these are 4 1/4 inch mortise holes. And a 1/2 inch wide. Now, because the mortise locations for the backrest of the bench are parallel to the edge of my angle cut, I need to do my angle cut first and then lay these out later. My goal is to have 2 legs that are the identical shape, and after creating my layout lines, I'm ready to bandsaw to the outside of the line, making sure I leave a 1/16 to 1/8 of an inch that I can flush cut router off later. This process is the same as the front legs. We do want to begin with a couple relief cuts on that inside angle. And with our rear leg pieces cut, we're looking pretty good. We want to reattach our leg templates just as we previously did with the front leg pieces. And we are again going to be using double stick tape in 4 different locations. And after peeling that backing paper off, we want to very carefully line up that template exactly with the lines that we have previously drawn. And with both those templates attached, we should be ready to move on to the next step. Our objective is to have 2 identically shaped pieces, with the exception of them being a mirror image with the mortise hole locations. We have attached our template to our workpiece, and we need to make sure that the router bearing is going to ride along the template. And hanging on to our workpiece, we can slowly feed that through the router. As we router, we want to progress at a medium to slow pace. We also want to listen to the cutting of the router against the wood. If it starts to split out or it sounds like it, we need to go slower. And as you will hear, this piece ended up not going very well. Now I did have one area that just caught the grain and there was nothing I could do, so I do have a little bit of tear out. Fortunately, it is on the side of the workpiece that will be facing the wall, so I'm not concerned about it. Now when I'm running the back portion, now one thing to be aware of is we want to avoid the mortise layout lines that we previously drew. Otherwise, we'll have to lay those out again. Aside from the one small part that blew out, everything went pretty smoothly, and the rear leg pieces are looking pretty good. With our rear leg pieces routered, we are done using the templates, so we can remove those. Our workpiece can be installed in the vise, and we can use a razor blade to gently cut the double stick tape while gently lifting off the template. If you only hang on to the handles, you make sure that you don't run the risk of cutting yourself with the blade. And we can come back and peel off the residual tape. And we will want to do that for the template as well. And that will leave us with 2 mirror image rear legs. We previously laid out the mortise locations for the rear seat rail as well as the seat side rail. Based on the template, we drew the location for the backrest, but we need to verify these measurements. On the drawing, the distance from the top of the top mortise to the top of the leg does not necessarily matter. What does matter is the size of the mortise and the 11 3/4 inch measurement. The 11 3/4 inch measurement is probably the most critical measurement of all of these. So we'll begin by keeping the top measurement measuring down 2 1/4 for our uppermost mortise. Then placing that critical measurement of 11 3/4, followed by our 1 3/4 inch measurement. And then we'll go back and verify the widths. And with the rest of those mortise locations laid out, we should be ready to move forward. The process for drilling the mortise locations follows the same procedure as we used for the front legs. We will need to put some additional blocks in to help our workpiece sit square. And as the plans indicate, we are milling all of these mortise locations 1 inch deep. And when finished, each piece should have 4 mortise locations, 3 on one of the faces, 1 on an adjacent face. These pieces need to be mirror images of each other. After mortising our pieces, they are looking pretty good. However, if we look down the mortise hole location, we can see fragments of wood and other splinters that might get in the way when we attach our connecting pieces. Clamping our workpiece in the vise and using a sharp chisel, we can clean up the mortise hole location. We can also clean the bottom of the hole. And I also like to come back with a little bit of sandpaper and sand down the side walls of the mortise hole location, as well as the edges. And with those all cleaned up, all 4 of our legs are complete. Taking a look at our project plans, we have 2 seat side rails. These components connect the front legs to the back legs. If we take a look at the drawing for our seat side rail for both the left and the right, we do have mitered tenons. This tells us that this piece is mortise and tenoned into the legs. We can see that the finished thickness of this piece is 1 1/8 inches. The lumber that we purchase from the lumberyard measures 0.95, or just under an inch. So we know that we will need to be gluing 2 pieces together to allow us to get this thicker size. If we look at our rough cut list, the seat side rail needs to be thicker than 1 1/8, because 1 1/8 is our finished thickness. We want to have a oversized width of 5 inches by an oversized length of 18 inches. I selected a board that is about 5 3/4 inches in width. This will yield me a 5-inch wide board easily. And I'm going to lay out 4 pieces that are 18 inches in length, because I will need to be gluing 2 of these together to make one side rail, and I have 2 side rails on my project. So this board will easily yield me 4 pieces that are 5 inches wide by 18 inches long. We are in the process of creating our seat side rail for both the left and the right side. Our rough dimension for our work pieces are 5 inches wide by 18 inches long. I did notice that one end of my board that I selected has a defect on it, so I'm going to begin cutting from the other end, which looks a lot nicer. And I always want to begin by squaring up that end. I can then measure and mark my board at 18 inches, making sure that I don't follow the chalk marks, and continue this process, cutting all 4 of my pieces. And when finished, I have 4 pieces measuring a length of 18 inches by more than 5 inches in width. Our seat side rail measures 1 1/8 inches thick. We are setting this up to glue 2 pieces together. Our rough dimension cut list calls for our seat side rail to be 5 inches in width by 18 inches in length. Right now, our work pieces have 1 milled edge from the lumberyard and 1 rough edge. We need to true up the milled edge using the joiner. We can then set our table saw to 5 inches, and with our good, clean, jointed edge up against the fence, we can cut each of our pieces down to 5 inches in width. Now, I am not concerned that I am creating a milled edge with the table saw blade, as these pieces will be glued together and resized down at a later time. And my 4 work pieces now measure 5 inches in width by 18 inches in length. To achieve my 1 1/8 inch thickness, I will need to glue 2 pieces together. I selected lumber that was pretty good to begin with, but we need to clean up the faces of one side of each of these pieces. Given that these pieces measure about 0.95, that's what I'm going to start my machine at. I'm also going to mark both sides of my boards so that when the pencil mark gets sanded off, I know that that surface is ready for glue. Now, although I am only sanding one surface, the other side with the pencil mark will tell me that that side needs to face out when I glue. And with one face sanded, I can flip those boards up and see how they will seat together. Specifically, I am checking for large gaps that would not be able to be taken out in a clamp. I also don't necessarily have a concern about the grain pattern facing the same direction on the end grain. These pieces will be glued together and planed down to 1 1/8 inches, so the effect of the grain pattern is pretty negligible. My objective is to create 2 seat side rails, one for the left, one for the right. that have a thickness of 1 1/8 inches. I have previously prepped my pieces and they are ready for glue. I am setting up my clamps about 8 inches apart. Any pencil marks are facing out so that I am making sure to apply glue to my good sanded surface. And I am wanting to glue my seat rail pieces together, but not the two rails together. With everything set up, we want to spread the glue across the entire surface of each workpiece. We then want to flip up each workpiece and clamp it together very gently, adding additional clamps, clamping it gently again, and then slowly snugging all of the clamps, making sure that the pieces haven't shifted on us. When everything is clamped up, we can wipe the glue with wet paper towel. We can then set that out of the way for 24 hours. After 24 hours, I can remove all of the clamps from my seat side rails, and I want to scrape off any excess glue. According to the plans, the seat side rails have a width of 4.5 inches. We need to begin with a jointed edge. Set our table saw to a 1/16 over 4.5. Make our cut on the table saw with the good clean jointed edge up against the fence, and then joiner that milled edge. And our two seat side rails are now at a finished width of 4.5 inches. Our seat side rail plans indicate that the finished length is 17 inches. Our pieces are currently sitting at an oversized length of 18 inches. And because I glued two boards together, my ends are not flush, and I need to make sure to square up the ends first by removing as little as possible. I can then set up a stop block at 17 inches and complete my cuts, making sure my previously cut edge is against the stop block. And I am now sitting at my finished length of 17 inches. According to the plans, my seat side rail for the left and the right needs to be a finished thickness of 1 1/8 inches. I am currently sitting at about 1.86. I need to come down to 1.125 or heavier than that. So I'm going to be removing quite a bit of material. And by leaving these pieces slightly heavy, it will give me plenty of material to finish sand off in the next step. And when finished, I ended at about 1.18 to 1.19. The finished thickness for my seat side rails, the left and the right, is 1.125 inches, or 1 1/8. I'm currently sitting about 1.19. So I will be finish sanding both surfaces, slowly bringing the machine down until I meet my 1.125 measurement. And when finished, I'm sitting pretty close to 1 1/8. These pieces are now sized to my finished thickness, width, and length measurement. Taking a look at our project plans, our seat side rail for the left and the right have mitered tenons. We're not going to worry about the miter cut yet, but we are going to lay out for the tenon. The length of the tenon is 1 inch. The thickness of the tenon is 1/2 inch. And we do have a 1/8 inch gap around a portion of the tenon, but a 1/2 inch gap around the other portion of the tenon. So this is an irregular type of a tenon that will have to take a little bit extra time to lay out. So we will begin by laying out the 1/8 inch portion on the end. Then we can lay out our 1/2 inch. This portion gets cut away. And these will then be 1 inch in. And we'll mark that all the way around. Now, although we only technically need to mark one end, we do need to be very careful when we get to the dado head to make sure that we don't get confused with the 1/2 inch portion and which end of the board or which face of the board we're cutting that from. Now, the reason for this irregular tenon is that the seat side rail sits flush with the inside face of the front leg and rear leg. And we are trying to minimize the amount of gap when the seat is closed. We'll begin by cutting our 1/8 inch deep sides. Now when we flip this to do the other end, we want to take the 1/8 inch cut off of the same 3 faces. And without moving the fence, I'm going to raise the blade to 1/2 inch and perform my next cut. And before I get too far, I do want to test this with my leg to make sure that it does fit and I don't need to do any minor adjustments. And this fits real nice, so I will continue finishing the tenons. And those tenons look good and they fit great into the leg pieces. Taking a look at our plans, we have mitered tenons. We need to cut a 45-degree angle, but we need to make sure we are cutting it in the right direction. Our 1/8 inch lip is on the back. Our 45-degree angle is coming forward towards our 1/2 inch lip. So I do not get confused on the miter saw, I'm going to make a couple small marks just so I can remember what angle I'm cutting it at. And I'm going to do this for both sides of both of these pieces. And with the miter saw set to 45 degrees, I can complete my cut. And those mitered tenons look really nice. With our front legs created, our rear legs created, and the seat side rails made, we can dry fit this together to identify any possible issues. We'll start with a front leg. Now the tenon fits very tight, so we're going to widen the mortise ever so slightly. and that solved that problem. We'll continue this process with all of our other pieces, see if there's any adjustments that need to be made, and make those adjustments. And you do want to make sure that you build it correctly, which is another reason why we dry fit, to make sure that all of the mortise hole locations are pointing at each other. Everything so far looks really good. Taking a look at our plans, we have a seat front rail. We have a seat rear rail. We also have a backrest lower rail, as well as a backrest upper rail. All of these pieces have identical lengths, so we will be creating all of these at the same time. If we take a look at the drawing of our seat front and rear rail, we can see that there is a length of 47 inches. If we take a look at the backrest lower rail, we have 47 inches. And if we take a look at the backrest upper rail, we also have 47 inches in length. The seat front and rear rail, which connects the sides of the project together, has an overall width of 3 3/4 inches and a thickness of 3/4 of an inch. These also have mitered tenons, so we need to account for that, and we need to think about that as we plan our cuts. The backrest lower rail does not have mitered tenons, but it does have tenons. With our backrest lower rail, we also have a mortise hole location for all of our slats. The backrest upper rail also has tenons, and it also has our mortise hole locations for the slats. The backrest lower rail is 2 inches width compared to the upper rail that is 2.5 inches in width. So we are working with 4 different pieces of varying sizes. The main commonality is the length of 47 inches. Our seat front and rear rail have a width of 3 3/4 of an inch. For these 2 pieces, I have selected a piece of lumber that is a little bit over 8 inches in width. I should be able to lay out both of these 3 3/4 inch pieces by 47 inch long and still have enough material to be able to clean up the edges. Additionally, I have very little waste. My backrest lower rail has a width of 2 inches, and my backrest upper rail has a width of 2.5 inches. By selecting a board a little bit over 5 inches, this one is about 5 1/4, I should be able to lay out both of these pieces and still have enough material to clean up the edges, all the while minimizing the amount of waste. Although the finished length of my seat front and rear rail, backrest lower rail, and backrest upper rail are all 47 inches, I need these to be identically 47 inches down the road, so I'm going to be cutting them to an oversized length of 47.5 inches. We'll begin by squaring up the end of the board, measuring and marking it at 47.5 inches, and then performing our cut. And we'll do this for both pieces. And I now have my two pieces at 47.5 inches. From these, I should be able to get my two backrest rails, as well as my two front and rear seat rails. Our front and rear seat rails have a finished width of 3 3/4 inches. The board that we have designated for both of these pieces has a width of a little bit over 8 inches. This allows us to get both pieces out of this board. However, we have one milled edge from the lumberyard and one rough edge. We need to clean up the milled edge on the joiner first. Now, although the plans say that the finished width is 3 3/4 inches, I'm going to set the table saw to 1/16 more than 3 3/4 inches. And with my good, clean, jointed edge up against the fence, I can complete my cut. Now the edge that touched the table saw blade now has mill marks on it. If we look real close, we can see burn marks and we can see rotational scratches. These mill marks need to be removed on the joiner, which removes 1/16 of an inch. So at this point, I have one piece sized to my finished width of 3 3/4 inches with two good jointed edges. I have my offcut piece that has a milled edge from the table saw and my rough edge. I need to joiner the milled edge, rip this to 1/16 more than 3 3/4, and then go back to the joiner and joiner off that 1/16 of an inch milled edge. And that leaves me with two pieces at my finished width of 3 3/4 inches, both of which have good, clean, jointed edges. They are both at an oversized length of 47.5 inches by a thickness of about 1 inch. My backrest upper rail has a width of 2.5 inches. The board I have deemed for this purpose, I have cut to an oversized length of 47.5 inches. Currently, as it sits, I have one milled edge from the lumberyard and one rough edge. I need to begin by joining the milled edge to clean that up. Now, although the finished width is 2.5 inches according to my drawings, I'm going to set the table saw to 1/16 more than 2.5 because the table saw will create a milled edge that I will need to clean up. And back to the joiner to clean up that milled edge. My upper horizontal rail now has a finished width of 2.5 inches by an oversized length of 47.5 inches. This is about 1 inch thick, and I also have my offcut piece, which I will use in my next process. Taking a look at our plans, our lower backrest rail has a width of 2 inches. The lumber remaining from our previous operation is more than 2 inches wide. It is 47.5 inches long, which is our oversized measurement. We have one milled edge from the table saw, and we have one rough edge. We want to begin by joining the milled edge to clean that up and prep it for the table saw. Although the plans state that the finished width is 2 inches, we're going to set this to 1/16 more than 2 inches because the table saw will create a milled edge that we will need to clean up. And back to the joiner to clean up that milled edge. And we have our lower backrest rail to a finished width of 2 inches and an oversized length of 47.5 inches by about 1 inch thick. According to the plans, our seat front and rear rail, as well as our backrest lower and upper rail, are all cut to a length of 47 inches. This is our finished length. There is a possibility that the ends of our boards are not perfectly perpendicular to the edge or perfectly 90 degrees. We want to begin by first re-squaring the end of each of these boards, taking off as little as possible. And before I do this, I'm going to mark the ends of all of my boards just so I can remember which ones I've cut. I'm then going to set up a stop block at 47 inches, which is our finished length measurement, and making sure to line up my cut end with my stop block so I am removing my uncut end. I can complete those cuts. And all 4 of those pieces are now sitting at my finished length measurement of 47 inches. My backrest lower rail is at 2 inches width. My backrest upper rail is 2.5 inches width, and my seat front and rear rails are at 3 3/4 inches width. The thickness of my seat front and rear rail, my backrest lower rail, and my backrest upper rail are all 3/4 of an inch. The current thickness is about 0.96 inches. I'm going to begin planing at 0.95 inches, and I'm going to bring these down to about 0.80, so just a little bit thicker than 3/4 of an inch. After planing, we are sitting at about 0.8, so we are 3/4 of an inch heavy, and this is ideally where we want to be at. The finished thickness for our seat, front and rear rails, as well as the backrest upper rail and backrest lower rail, all measure 3/4 of an inch, or 0.75. After planing, we are sitting at about 0.8. This will leave plenty of material to be able to finish sand and remove any mill marks from the planer. And I'm going to start by marking both sides. And I'm going to start the machine at 0.775, which is just a little bit under where I'm currently at. I will then bring the machine down to 0.75 and run the other side of the board, and then they should be finished. And when finished, all of our rail pieces are exactly 0.75 inches thick. We have also sized down the width and the length. Taking a look at our seat front and rear rail drawing, our tenons are 1 inch in length. These are mitered tenons, but we are not going to worry about the miter at this point in time. Looking at the backrest upper rail, we also have a 1-inch tenon, as well as on the backrest lower rail, we have a 1-inch tenon. The distance around the tenon is 1/8 of an inch, or the shoulder cut is 1/8 of an inch. Our objective is to lay this out on our workpieces. So essentially, we are creating identical tenons for all 4 of these pieces, with the exception of the miter, which we're going to do at a later stage. So we're going to lay this out on one end of one piece. We're going to base our saw setup based off of this one end so that all of them will be identical. On the ends, we are going in 1/8 of an inch. On the face and edges, we are going in 1 inch. With our tenon laid out, we're looking pretty good. After having laid out all of our tenons and setting up the dado saw to our layout marks, I'm going to cut my first tenon. Now these are a little harder to hang on to because they are long pieces. And with one of our tenons cut, we're going to verify that everything still lines up, all of our measuring was good, and that we don't need to make any minor adjustments. This one fits real nice. I'm going to continue and cut all of the rest of my tenons. And we can take a look at the tenons once they're cut and make sure that there's no areas that need to be cleaned up before we move on to the next step. As we take a look at our plans, the seat front and rear rail have mitered tenons, and we have previously cut our tenons to the correct size. Now we just need to miter them. And as we do this, we want to make sure that both of those miters are on the same face. Essentially, we are making a trapezoid. And to make sure I don't get confused on the miter saw, I will be marking both sides of this. And with our miter saw set to 45 degrees, we can complete both of our cuts. And with that cut complete, both miters on both ends of both boards have been cut. I have previously assembled both of my sides. Now having my front and rear rails completed, as well as the backrest rails, I can dry assemble this together. Now it may help to gently clamp one side to the workbench and then work those rails in place. And the dry assembly is just a little bit too snug, so we're going to widen the mortise location ever so slightly. And that fits much better. And with those first few pieces in, we can see if there's any touch-up work that needs to be done to the other side as well. And with each one, I do like to number them just to make it a little bit easier to reassemble this at a later date. And with those pieces together, everything should fit nice and snug. Nothing should have been forced to fit. The bench should stand on its own, and there should be no large gaps between the joining surfaces. Taking a look at our project plans, we have 8 seat slats. Those run between the backrest upper rail and the backrest lower rail. We have already created the backrest upper rail and the backrest lower rail. So our focus is on making the seat slats and getting those to fit between my backrest upper rail and my backrest lower rail. According to the plans, the total length of my backrest slat is 12.5 inches. However, the visible area is only 11.5 inches because I do have tenons on the ends of these seat slats. And I first want to verify that 11.5 inch measurement. Now on my project, I am actually sitting 11 7/16 is the viewable area. So I need to remember this throughout the process of making these seat slats. However, for right now, I just need to make sure I have enough lumber to make 8 seat slats measuring about 12.5 inches by 2 1/4 inches wide. I have a variety of my offcut pieces, and my goal is to get 8 12.5 by 2 1/4 inch pieces. So with these pieces, I should be able to get 8 seat slat pieces if I laid things out correctly. Now, one of my pieces does have a small defect in it. Because this is a part of the project that people are going to see, I'm going to get an additional piece of lumber and not use this piece. This now should yield me 8 pieces, 12.5 inches long by 2 1/4 inches wide. Now, all of these seat slat pieces are going to be identical lengths, which I will be stop blocking later on the miter saw. For now, I will be cutting each piece to an oversized length of 13 inches. And after squaring up one end on each of these boards, I can measure and mark my boards at 13 inches, which is my oversized measurement, and cut it to that oversized measurement. And I am left with a stack of lumber, all of these pieces measuring an oversized length of 13 inches by varying widths. I should be able to get all of my backrest slat pieces out of this pile. My backrest slat has a finished width of 2 1/4 inches. Currently, my boards have a variety of widths, and each of these boards have one milled edge from the lumberyard and one rough edge. Cleaning up that better milled edge on the joiner with each of these boards will give me a true edge that I can then bring over to the table saw. I can then set the table saw to 1/16 more than my finished measurement of 2 1/4. And with that good, clean, jointed edge up against the fence, I can cut all of my pieces. And any pieces that I have ran through where I am getting 2 pieces out of 1 piece of material, I need to remember that I now have a milled edge. So there's saw blade scratches. So I want to joiner that milled edge, run my piece again before I move on. And I now have 8 pieces, each with a good, clean, jointed edge, as well as a milled edge from the table saw. Each of these pieces I then need to run through the joiner to clean up that milled edge and remove that extra 1/16 of an inch of material. And that leaves me with my 8 backrest slat pieces cut to a finished width of 2 1/4 inches. The plans for our backrest slats call for it to have a length of 12.5 inches. The visible area, this is not including the tenons, is 11.5 inches. Each of those tenons are then 1/2 inch. Currently, our backrest upper rail and backrest lower rail have a very good fit with the rear legs. If I measure the distance between my opening, which is my visible area for the slats, I get a measurement of about 11 15/32, which is 1/32 less than 11.5. I'm going to take this measurement at both ends and verify that the measurement is the same. In this case, it is. My visible opening is 11 15/32 of an inch. If I were to make this piece at 11.5 inches, that would push my lower backrest rail down 1/32 of an inch. Now I can widen the mortise hole location 1/32 of an inch down, and this will accommodate this variant. And because I have this flexibility, I'm going to proceed with making my backrest slat according to the plans at a finished length of 12.5 inches. And then each of these pieces will be re-squared and then stop blocked to a finished length of 12.5 inches. And when finished, my 8 pieces have a finished length of 12.5 inches by a finished width of 2 1/4 inches. My backrest seat slats have a finished thickness of 1/2 inch. Currently, my pieces are sitting at about an inch. I'm going to be planing these down to 1/2 inch heavy. 1/2 inch is 0.50. I'm going to be going to about 0.55. This will leave me a little bit of material to finish sand in the next step. And as we send these pieces through, we do want to alternate sides, so we are cleaning up both faces. And I ended at about 0.57, which gives me a little bit of material for finish sanding. Our finished thickness is 0.50 inches or 1/2 inch. We are currently sitting at about 0.57 inches. That gives me about 7/100ths to remove. On my wide belt sander, I'll start at about 0.55. And just as we did with previous components, we will mark both sides and slowly bring the machine down, alternating sides until those pieces come out to our desired measurement. And after sanding both sides, I'm sitting at about 1/2 inch. With all of my slats sized down to the final measurements, I'm going to shift my focus to the backrest upper rail and the backrest lower rail. Taking a look at both of these drawings, we can see that there are a series of mortise hole locations. If we take a little closer look, we have a set of very specific measurements for each of these locations. So we will temporarily disassemble part of our bench. We then want to clamp both pieces together in place, making sure that the ends are lined up perfectly and the edges are perfectly flush. We want to verify the length of these pieces are 47 inches, and then we can put our first mark at 23.5 inches. We then want to measure over 1 9/16 in either direction, and we can use a square to extend those marks. Taking a look at our plans, each of the mortise hole locations measure 2 1/8 inches. Each of the gaps between them are 3 1/8 inches. So we have 2 1/8 inches followed by 3 1/8 inches. This will continue for the entire length of the workpiece. Now my 2 1/8 inch locations are my actual mortise holes that will be drilled out. And I'm going to put some light X's on these 2 1/8 inch portions to give me a visual clue of what needs to be cut out, so I don't accidentally cut out what I shouldn't be cutting. Now if I look at my backrest slat plans, this tenon is only 3/8 of an inch. This is different from the previous tenons that I've made on my project. I'm going to lay out one of these locations as 3/8 of an inch so I can set the machine properly. And because we did clamp these together prior to layout, all of our lines should match up perfectly. With all of our mortise locations laid out, we are ready to transition over to the mortising machine. However, if we first look at the backrest slat tenon, this is a 1/2 inch tenon, which means our mortise hole location needs to be set to slightly more than a 1/2 inch. And with our machine set up, we can cut each of those mortise hole locations. And because I cut those mortise hole locations just a little bit deeper than I needed to, I shouldn't have to clean up the bottom of any of the holes. Moving back to our backrest slats, we need to lay out the tenons. Now these go in a 1/2 inch, and we have a 1/16 inch shoulder around the outside. Now I should be able to lay out one of these, set my saw to that measurement, and then be able to cut all of them and have them identically the same. So we'll begin with our 1/16 measurement around the outside. And then we're going to come in a 1/2 inch. With my tenons laid out, I can set my saw to my marks and begin by only cutting one end first. And then I'm going to test it. This one's just a little bit too tight, but I did intentionally set the saw a little bit lower than it should be. So I'm going to bump up the saw just a tad, run this again, and then test it again. And this time it fits very nice. So I can cut all of the rest of these to this setting. And after that, all of our tenons are finished on both sides, and we are ready to see if all of this goes together. We are currently working on the seat back. We have our upper rail and lower rail complete. We also have our 8 seat slats complete. We need to make sure that all of this is going to fit together in this stage so that when we move on to the glue stage, there's no issues. I found one that was a little bit too tight, so I'm going to clean that up on the dado. That fits better now. We want them to fit snug, but we do not want to have to force them in. Assembled, all of these joints look very nice. We also want to assemble the backrest onto our project. If you remember, there is a possibility that this is a 32nd of an inch too big, and we might have to open up one of the mortise hole locations, but we won't know until we assemble this together. And as expected, I am ever so slightly off. If I take a closer look, I am actually off by about a 1/16 of an inch. And if I widen the mortise hole down, I run the risk of exposing a little bit of the top edge of this hole. So rather, my top mortise hole location, I'm going to widen the hole upward about a 1/16 of an inch on both sides. And then we can see if that fits. And that seemed to do the trick. Everything is lining up really nice. All of the joints look very tight. There are no large gaps or pieces that are loose. Everything is fit snug. Nothing is forced. Our project is dry assembled and everything works good. Everything fits good, everything looks nice. We want to glue up only the seat back, which means just the connection points where the slats meet the rails. Everything else is going to be held in place so that everything is in the correct position, but the only glue we're applying at this point is to secure the slats. So we need to do just a little bit of disassembly. What's left of the bench I'm going to leave as is because we're going to glue up the seat back and then install it on the project. I'm also going to sand any of my pencil marks, as these will be near impossible to remove after this is glued up. And we're going to be applying a small amount of glue to the mortise hole locations. And using a brush, we can spread that around. We'll do this for each location. Install our back slats, assemble this backrest, and then put it on the project. We need to do all of this within 10 minutes before that glue starts to set up. And to help keep everything tight and in place, I'm going to add just a couple clamps with just a little bit of pressure. I then want to go around and double check every joint to make sure that everything is perfect. And we're going to let that sit just like that for 24 hours. With our slats all glued into place and the rest of our project just dry assembled, we're going to start focusing on the armrests. Taking a look at our plans, we have 2 armrests. These pieces are mirror images of each other as well. The curved portion needs to face outward. The flat edge needs to face inward to give clearance for the seat. Taking a look at the armrest drawing, we have a width of 3 inches and a length of 19 1/4 inches. Taking a look at my rough dimension cut list, I will be sizing this to 3 inches width, which is my final measurement. I'm not going to do an oversized width. I am, however, going to add a little bit on the length and then bring that down later. So I need a piece of lumber that I can get 2 20 1/4 inch long pieces. So I will be laying out 2 20 1/4 inch long pieces by 3 inches wide. And this board should yield me enough material for those 2 pieces. On my armrest drawing, my finished length is 19 1/4 inches. However, I will be cutting this to an oversized length of 20 1/4 inches. I have 2 armrests, so I will need 2 pieces. And because I am using an off-cut piece from a previous board, my first end is already square, so I can measure, mark, and cut each of these pieces. And my 2 boards now measure an oversized length of 20 1/4 inches. My width is quite a bit more than 3 inches, and my thickness is at about 1 inch. Taking a look at my armrest schematic, I have a finished width of 3 inches. My rough cut dimensions indicate that I can bring this down to my 3-inch finished width at this stage. And on my 2 boards, I have 1 milled edge from the lumberyard and 1 rough edge. So I will begin by cleaning up that milled edge on the joiner. My table saw can then be set to 1/16 over 3 inches, and I can cut both of those pieces. Each of these pieces then have 1 good, clean, jointed edge and 1 mill-marked edge from the table saw. I want to clean up the mill-marked edge on the joiner. And when finished, I have 2 work pieces measuring my finished width of 3 inches by my oversized length of 20 1/4 inches by about 1 inch thick. Taking a look at my plans, my finished length is 19 1/4 inches long, and I am currently sitting at 20 1/4 inches long. I'm going to mark the ends of both of my boards. This will help me remember which end that I've cut, and I will begin by squaring up one end of each of these boards. We can then set up a stop block at 19 1/4 and cut the other end of our boards off. And I am now sitting at my finished length of 19 1/4 inches. Taking a look at our armrest schematic, we have a finished thickness of 0.75 inches, or 3/4 of an inch. We're currently sitting at about 1 inch. And we want to plane both sides of these boards down to about 0.8 inches, which is just heavy of 3/4. We want to leave a little bit extra material so we can finish sand these during the next step. And this then puts me at about 0.80, or just a hair over, which will leave me a good amount of material to finish sand off. According to our plans, the finished thickness for the armrest piece is 0.75 inches. We are sitting at just over 0.80 inches. And I'm going to start my machine at 0.775. And I am going to mark both faces on both of these boards so I can make sure the sander is taking off material. And when finished, my armrest workpieces are at a finished thickness of 0.75 inches, a finished length of 19 1/4 inches, and a finished width of 3 inches. Taking a look at my plans, I can see that I have an irregular end on my armrest piece. I am at the point where I'm ready to lay this out. The radius is 6 3/8. However, I do have a full-scale template that will allow me to draw this out a little bit quicker and a little bit easier. I can then set that template on my workpiece and trace the contour. And I will want to do this for both of my pieces. And although these pieces will be mirror images, it technically doesn't matter at this point because we could always flip the piece over and that curve would be on the opposite side. The only thing that would matter is if you had a certain grain pattern you wanted people to see or perhaps hide. We are in the process of creating the armrest. Specifically, we are working on the curved end. We have laid out both of the curves on our workpieces, and we now need to bandsaw them to an oversized shape. We want to make sure we are staying at least a 1/16 to an 1/8 of an inch away from the line so we can sand down to the line in the next step. It is critical that we stay away from the line. And with both of those ends cut to our oversized shape, making sure that we left the line, we are ready to continue on. We are currently shaping the end of our armrest pieces. We are cut to an oversized shape, and we have left the line, which will give us the chance to sand down to the line perfectly. On the spindle sander with our large diameter installed, we can slowly bring that down just to the line. And I do like to lay this out on the bench just to verify it doesn't overhang. This one's looking really nice. Taking a look at our plans for the armrest, we have an angled end. Specifically, we are angled to 84.82 degrees. Now this angle does correspond to the angle of the backrest, so it should seat in there nice and tightly. What we need to be careful of is that these pieces are mirror images of each other. So we need to lay this out to make sure that we don't cut the wrong angle on the wrong piece. I'll set my first one in place, making sure my curved end is facing out. Then I'm going to draw the angle of the backrest This is a visual guide only, and I'll do that for the other side as well. And I'm then going to set my saw to 84.82 degrees, which is also 5.18 degrees, and lock that in place. I then want to verify that I am cutting the right angle on the right piece, because I am creating mirror images of each other, and I can complete my cut removing as little material as possible. We'll move the saw to 5.18 degrees in the other direction, lock it down, and complete our cut. I can then verify that fit on my project. Although we have dry assembled a portion of our bench and the backrest slats are glued in, we are going to disassemble this and only dry assemble the sides. So I have my two side assemblies laid out and nothing is glued. I'm going to flip these so the mortise is facing down. So we are looking at the outside of the project. And if we look at our plans, the curved edge of the armrest is facing the outside of the project. The inside edge is flat, or rather those pieces are all flush. So if I set that up the same with my work pieces, making sure we put the correct angled piece on the correct side, the curved edge is facing out, and what is touching the workbench is the flat side, or is the inside where all of those pieces are flush. Now my critical measurement with this armrest is that the distance from the seat side rail to the armrest is identical. And we want to be measuring this as close as we can to the front leg and as close as we can to the rear leg. And to prevent anything from moving while I lay this out, I'm going to loosely install a clamp, and the distance from my front needs to be identical to the distance on the back. I am at 6.5 inches exactly. So we're going to set our back to 6.5 inches exactly. And then I'll make a mark on both sides. On our project, we do have a connection point between the armrest and the front leg. This will be connected with a dowel. So our objective is to lay out this placement of the dowel drill hole. On the front portion of the armrest, I am also going to trace the front leg. I can then take all of this apart and clamp my leg in the vise. And we will be making an X from corner to corner, which will help us place the dowel location. And I can do the same on my armrest. And with both of those laid out on both of the sides of our project, we now have our dowel drill point location. On our project, we have a connection point between the armrest and the front leg, and we have previously laid out our drill point locations for our dowel, which will be holding this together. Our dowel measures 0.622, or about 5/8 of an inch, and our Forstner bit also measures about 0.62, which is 5/8 of an inch. On my leg, I'm going to be drilling down 1 inch depth. So I have applied a small piece of tape to my Forstner bit to remind me when to stop. And on my armrest, I want to make sure that I do not drill all the way through. So I'm going to set the drill bit up against my workpiece and apply a small piece of tape at the point that I know I will not be drilling through the entire workpiece. I can then clamp my workpiece and drill down to my tape. And I will want to do this for both sides. And when finished, I have corresponding dowel holes that should line up perfectly. And with those holes drilled, I'm going to cut a couple 1 3/8 inch pieces of dowel, sand the pencil marks off of my armrest pieces, and install those dowels with just a little bit of glue, and wipe any excess glue. At this point, we're going to dry fit our side assemblies together again, this time making sure that the dowel location does line up good and that there are no other issues. And everything is looking good so far. Now, I had previously measured my distance from my seat side rail to the armrest at 6.5 inches. I'm going to be installing 2 blocks that are exactly identical, 6.5 inches, and clamp those in place. These blocks will serve as spacers for the next process. And we'll add an additional clamp. What we're trying to do is hold everything in place perfectly so it won't move. And our goal is to add a series of clamps so that everything lines up perfectly and nothing's going to move on us. I'm then going to flip it around and add an additional clamp on the curved portion of the armrest. And what I'm trying to do is force the opposite side down against the workbench so it is perfectly flush. So our joining pieces, the armrest and our rear leg, should be nice and tight. We also want to be perfectly flush against the table. With this assembly dry fit and with clamps, everything is connected together as it should, and there are no issues. Taking a look at our plans, we are working on the armrest. We have taken care of the connection point at the front of the bench, which is done with a dowel. The connection point at the back of the bench is now what we are taking a look at. When we dry fit our side together, we installed 2 blocks that were identical lengths for the identical size of the opening. We added a variety of clamps, and specifically we added 1 clamp onto the armrest and the back leg to make sure that we are flush on the other side of the project. Now, at this connection point, we will have 1 screw running through the project from the rear of the back leg into the armrest. Temporarily, I'm going to remove my clamp and mark at the connecting point for my armrest. And I'm then going to transfer those marks down. And to pinpoint the center location, we can use our X method. And any clamps we moved can be replaced. And we do want a clear path for drilling, so our clamp holding the curved portion of the armrest needs to be pushed out of the way a little bit. We can then use a 3/8 inch Forstner bit to drill about 3/8 inch deep. We can then follow that with a 1/8 inch pilot hole bit. We want to drill a little bit deeper than the length of the screw. The screw is 2.5 inches long. Now, we are also drilling at just a slight angle because we want to go squarely into the armrest. And then we can slowly install the screw just until it's snug, listening for any cracking or popping of the lumber. Removing our clamps, the dry assembly process with that rear screw is complete. At this point, we have both of our side assemblies assembled with no glue and only one screw at the back of the armrest. Our objective at this point is to double check that everything fits together as it should and get these glued up. Now we're doing these one at a time, what we have previously assembled. And before I glue, I do want to sand off any pencil marks. And with all the pencil marks sanded off, we are ready to glue. Now once we start applying glue, we have to have everything perfect within 10 minutes. And we want enough clamps and support that everything will be held tight until the glue dries so that we don't have any gaps. We'll do the other side and let these sit for 24 hours. Now you will want to pay attention to the inside of the corresponding mortise hole location for our front and rear seat rails. We don't want too much glue to build up inside of here, otherwise those corresponding rails will not fit in. So we need to go back and clean that up as best as we can. Taking a look at our plans, we can see the seat, which opens and closes on our project. The seat fits between the armrests as well as the seat side rails. Our rough cut dimensions for our seat measure more than 18¼ inches by 46 inches in length. I have selected a variety of boards to use in the creation of my seat. Each of the boards measure more than 46 inches in length because that is my oversized measurement. If I combine all of the boards and measure the width, it equals more than 18¼ inches. My pieces measure about 24 inches, but you have to consider we will be cleaning up the edges, joinery, table saw, so on and so forth, so this number will go down. So we have to estimate that all of these pieces together, once cleaned up, will be more than 18¼ inches. Next, I'm going to note any defects on the workpieces, flipping them over and looking at both sides. The seat is the main area that everyone will see, so we want the best lumber choice and the best grain pattern. In general, we can lay everything out from the best end of the board. Now, as the boards sit, I end up using about 50% of my lumber. The other 50% technically ends up being waste. This is the point of your project that can either be very expensive or we can use the material a little bit more efficiently. The boards are not quite long enough to get a second piece out of for my seat. However, if we were to make the seat earlier on in the project, we could reuse all of these off-cut pieces for other components on our project. Or we could use those pieces for an additional project. Looking at our plans, the distance between the armrests is 45 inches. The rough cut dimension shows that our seat length is 46 inches. This is our oversized rough cut dimension. We want to begin by first squaring up the end of each of these boards. We can then measure and mark these boards at 46 inches. Do not follow the chalk lines. Create new cut lines with a pencil. We can then complete our cut at 46 inches. And at this point, we have 5 pieces of varying widths. They all are cut to a length of 46 inches. If we combine them together, we have a width of 23 3/4 inches. Our objective based on the rough cut list is that we need to be more than 18 1/4 inches. So we're still looking good at this point. Our seat will be composed of multiple boards glued together. We need to prep all of our pieces for glue as we will be edge gluing these boards together. As it sits right now, all of our boards have one milled edge from the lumberyard. We also have one rough edge. We need to begin by cleaning up the milled edge on the joiner so that we have a nice true edge for the table saw. And with our good, clean, jointed edge up against the fence, we want to adjust the fence with each cut so that we are removing the least amount of material, which will leave us with the maximum amount of material width-wise. We are just cleaning up the other edge, for which we will then joiner once we have table sawed each piece. One of my pieces, I have a pretty bad corner here, so I need to bring the saw in a little bit further to eliminate that so it won't cause me problems in the gluing process. Additionally, one of my boards has a portion of a knot, so I'm going to bring this in about 3/4 of an inch so that I can remove that. Again, I don't want problems during the gluing process. And because I created a milled edge on the table saw, I can go back through the joiner and clean up that milled edge before laying these out for glue. If any of your boards are wider than 6 inches, you may want to consider ripping those down in half and joining both of those milled edges, because if we have really wide pieces, we run the risk of that seat bowing or twisting. If we can have narrower pieces, it reduces the chance of this happening. Case in point, the top of this end table is only 2 wide pieces of lumber, and if we put a straight edge on it, we can see that it has cupped. The widest board that I have is about 5 3/4 inches, so I should be all right to use all of these boards. The seat of my project is composed of multiple boards that will be glued together. We have prepped all of the edges of all of the boards so we can then lay out our boards prior to our gluing operation. I'm looking for a couple things. First is the end grain. I want to make sure that the end grain is alternating. If I look at my first board, I can see that the end grain is going down. My next board, it is also going down. The next board is going up, followed by another piece going up, and then down again. So I'm going to switch these around a bit. Down, up, down, up, down. So at this point, my end grain is alternating. I can now shift my focus to the face grain. I want this to look like one big board, if possible. It'll never look perfect, but we can do the best we can to line up our grain. If I add some marks to accentuate the grain, I have real tight grain on this board, and I have real wide grain on this one. Those don't line up very good, so perhaps I'm going to rotate this around. Now, rotating it this way does not change the end grain. My end grain is still alternating from the previous piece. Now, if I accentuate that grain, I have pretty straight, tighter grain right next to each other, so I'm liking the way that looks. So I'm going to move on to my next piece, following the same procedure. And I'm going to work through, and I'm shifting my pieces around until I have a good looking grain pattern across all of the pieces. And we can shift pieces around, but we always want to go back and make sure that the end grain is alternating. So I have two pieces going down, so I'm going to flip this end over end. Same with this one. And then check my grain pattern again to make sure that I'm still liking it after moving the pieces around. I think everything looks pretty good here. Next, I'm going to number each of the joints. This will help prevent me from getting confused when I bring these back to the glue area. After that, I'm going to squeeze the boards together, and I am looking along each joint to see if there is a gap that's going to pose a problem in the gluing process. If you have a large gap, that means you need to re-joint or re-true up one of the edges, put them back together, and see if you can close that gap. If you can close the gap with your hands, you will not have a problem with the clamps. At this point, everything should be prepped, and I should be ready for glue. I am setting up my clamps about 12 inches apart, and then orienting my lumber according to my numbering of the different joints so that everything still lines up the way I laid it out. And I can verify that I laid it out correctly based off of my numbering of the joints. Each edge will then get glue, and I need to spread this around to coat the entire edge surface. I can then flip down all of those pieces and pull these pieces together. I want to very gently apply a little bit of pressure with the clamps, making sure my pieces don't shift around. I can then add additional clamps to the other side, giving that just a little bit of pressure as well. And then I can go through and snug each of the clamps. What I don't want to do is over tighten any of the clamps. We can then wipe all of the glue that has squeezed out on both the top and the bottom using wet paper towel. We can then set that aside for 24 hours. Taking a look at our bench plans, the seat runs from the back of the project to the front of the project, and we also have a small overhang on the front of the project. Based on our final dimension cut list, the seat needs to be a finished width of 18 1/4 inches. However, I do want to verify this measurement with my dry assembled project. Previously, we have glued up our side assemblies, so so I can unclamp those and dry assemble my entire project. And with that rough assembly, I can verify my measurement. Right now my opening is a little bit over 17 1/4 inches. This is including my front and rear rails. The seat sits on these rails, so that will leave me with about an inch overhang on the front of my project, which will be perfect. And with my top having been glued up more than 24 hours ago, I can remove those clamps and hang them up. And any excess glue on your workpiece can be scraped off. Now, although I have previously jointed all of my edges, I do have clamp marred edges. This is where the clamps dug into the edge. I want to first clean up one edge on the joiner. I can then set the table saw to 1/16 over my finished measurement. And then come back and joiner off the mill marked edge from the table saw. And now our seat has a finished width of 18 1/4 inches. Taking a look at our plans, the finished length for our seat needs to fit between the armrest assemblies. We have a total of 45 inches between the armrest assemblies. Our parts list calls for the seat to be 44 3/4 inches. So our seat will be 1/4 of an inch smaller than the opening between the armrest assemblies. This will allow for a little bit of flexibility to prevent that seat from hitting those armrest assemblies. Right now I'm sitting at 18 1/4 by 46 inches. So we can trim up our first end on the panel saw, taking off as little as possible just to square up that end. We can then slide down our workpiece. Before I cut my seat to the final length measurement, I do want to verify this with my project. And this opening is 45 inches, so I'm looking good. Measure and mark it at 44 3/4. And I can then complete that second cut. And I am now sitting at my finished length measurement of 44 3/4 inches by my finished width measurement of 18 1/4 inches. According to our final cut dimensions, the seat has a thickness of more than 3/4 of an inch, or rather, we don't want the thickness to get under 3/4 of an inch. The seat is the piece of the project that will get the most amount of wear. Over the course of 50 plus years, the seat will get beat up and you may need to refinish it. Leaving it a little bit thicker will give you just a little bit more material to work with. So our objective at this stage is to plane off as little material as possible, just so we have a nice, smooth, finished surface. We're going to be taking small amounts off on the planer, checking the surface each time, and then making an assessment if we need to take more off or not. I was able to end with a thickness of about 0.84 inches. I have one area that needs to be cleaned up a little bit more, but I think I can clean this up with one pass on the wide belt sander. Aside from that, both surfaces are looking really nice. The current thickness of my top is about 0.84 inches, And according to my final dimension cut list, I want a thickness of more than 3/4 of an inch. So I should be able to send both sides through the wide belt sander, first beginning at 0.84 inches, and then bringing the sander down 1/100th inch at a time until both surfaces are perfect. I anticipate finishing with a thickness of 0.80 inches, which will allow me to fall within that specification of it being more than 3/4 of an inch. After that, I can double check my surfaces, both of which are looking good. And I ended up finishing a little bit thicker than I anticipated, which is perfect. And if I place that into position, I'm also looking really nice. I have just a little bit of movement that will help with the clearance of this opening and closing. Taking a look at my project plans, my seat opens and closes. The pivot point is the back of the project, and we will be installing a piano hinge that is 30 inches in length as our joining component to allow our seat to open and close. On the front of our project, we do have that 1-inch overhang, and on the back of the project, our seat is sitting flush with our rear rail. And our objective is to install a piano hinge between that rear rail and the seat. Now this will raise up the back of the seat, so we need to account for this in our next operation. But we need to first figure out where exactly this is going to go. Our opening measures 45 inches and our hinge measures 30 inches. This will leave 7.5 inches on either side of the hinge. So that hinge then lines up with both of my marks. However, I will be using a flush cut router bit to help make this. That flush cut router bit is round, which is going to end up leaving a small radius at the beginning and the end of my cut. So to account for this, we're going to make our mark about 1/8 inch beyond our previous marks. We can verify those measurements with the hinge one last time, and our layout is looking good. With our hinge marks correctly laid out, we need to install a guide for the router bearing to follow. And I'm going to remove that back piece. And what I'm going to be doing is taking my back rail piece, a scrap piece that I've cut perfectly straight, and my hinge, and I'm going to stack these together, moving that scrap piece up and down until that hinge is perfectly flush with the top surface of my back rail. However, I'm first going to install some double stick tape to that scrap piece of lumber that I cut perfectly straight. This piece will then be stuck to my back rail piece, which will act as a template for the flush cut router bit bearing. Now it is very important that the straight scrap piece that we are using as a template extends beyond the lines that we've drawn. Otherwise you'll run into problems with the router. We can then move to the router and very carefully make sure we are adhering to the lines that we drew. And before I take that template off, I am going to double check that the hinge will sit flat between those routed radii. And this is looking really nice. And with everything looking good, we can cut away that template piece and clean that tape off. Because we have mitered tenons, it does matter the orientation of the back rail piece. So I'm going to temporarily dry fit this in place for laying out the hinge. And that hinge pin will be hanging off the back of the project. So I'm just going to draw a small arrow so that I can remember this is the back of the project. And I can pull that piece out. On our hinge, we have a paint clearance, which almost looks like a little cut mark into the hinge. This paint clearance will be our reference line. And that paint clearance line needs to be lined up with the back edge surface of our workpiece. This is the point at which we need to make our marks for the drill location for the screws. Only when that paint clearance line is lined up perfectly with that back surface. And we also want to double check our clearance with the radius so we are centered in that routed slot. And with everything lined up, we can mark our first hole location. Using a scratch awl or the tip of a screw, I'm going to put a small divot right in the center of that hole location and drill my pilot hole 3/32 of an inch in diameter. I'm going to drill that just a little bit deeper than the length of the screw. Applying just a little bit of bar soap to the threads of the screw will help it install a lot easier. We do want to install this by hand without a drill. Now I have the first screw installed. I am only going to install 2 additional screws at this stage. That will leave me the ability to adjust the hinge if need to at a later date. The process is the exact same for the center as well as the other end. We need to line up that paint clearance line, mark our hole location with a scratch awl or screw, drill our pilot hole, and install a screw. And again, we are only doing this at 3 locations along the length of the hinge. I'm going to dry assemble this again to lay out the hinge location for my seat. And we need to make sure that the surface facing up is the one that we want everyone to see. So we might need to flip this over, check the other side. This here is the surface that I want to be the top. Now from the back, we can see where that routed portion has allowed the seat to sit flat on that rear rail. So I'm going to put a little arrow pointing to the location where the hinge needs to go. That arrow is not determining the left to right positioning of the seat, just that the hinge needs to be connected here. I can then take that back apart, and setting that together on the table, I can see my arrow, and this will be pivoting as such with that hinge connected underneath here. And I'm going to place a piece of scrap material underneath that rear rail so it can sit flat. This will allow me to adjust my left and right as well as my front to back to line up this hinge. And if you remember from the drawings, our opening is 45 inches, but the finished length of our seat is 44 3/4. This means that when I lay this out, that rail needs to be extended beyond the seat by about 1/8 of an inch on both sides. Additionally, my paint clearance line on the hinge needs to be lined up with the back edge of that seat. To simplify this process, I have first clamped my rear rail and scrap pieces of material to the table, positioned my seat piece, clamped that to the table, and then made sure everything was lined up perfectly. This will allow me to drill 3 hole locations and install 3 screws. Only having 3 screws installed at this stage will help us with those adjustments later. And we can then install those 3 screws by hand with just a little bit of bar soap on the threads. With 3 screws in the rail and 3 screws in the seat, I can remove any additional clamps I have and reassemble this together to dry fit these components on my project. One of my goals is a uniform gap from the rear of the project to the front of the project at the point where the seat meets the side rail. And another objective is a nice uniform gap on the left as well as the right side of the seat. This is fairly easy to attain because nothing is actually glued up, and we can adjust pieces as needed. But once all of the adjustments are made, we need to double check all of the joint connections for the front and rear rail and side assemblies. We also want to test the clearance of the seat and the side assemblies. If you are hitting, this needs to be adjusted at this point. Everything is looking good on my project so far. We are ready to install the rest of the screws, so we need to disassemble this again and bring this over to the workbench. And with our project set up like we had it before, we can drill the remaining screw locations and install those screws. And for the rail side, I'm going to set this up in 2 vices and work through that same procedure. As of right now, we have our bench sides assembled and glued. We have our seat back assembled and glued. And we have our seat with the rear rail assembled with the hinge. And we are at the point where we are able to put everything together. And to set this up, I'm going to get all of my pieces ready to go. Next, any remaining sanding needs to be done at this point because it'll be very difficult to sand once this is assembled. Now, when we start this gluing process, we have to be finished and everything perfect within 10 minutes. So I need to have all of my parts set up and laid out. I need to have all of my clamps ready, as well as any other materials. And I will begin by applying glue to the mortise hole locations. I do have my project hanging off of the table because that armrest extends beyond the edge of the project. With that glue installed, I can install my front rail, followed by my back rail. That then followed by my back rest. This does work best if you have multiple people helping you. In an attempt to reduce the amount of glue that's going to drip on the project, I will apply the glue to my other side with it laying flat on the workbench. And with that glue applied, I'm going to tip the bench up and slowly work the side assembly onto each of those tenons, making sure I get them lined up precisely. So I'm going to add 4 clamps, each running along the length of each of the rails for the seat rails and the backrest rails. I'm going to do this very methodically to make sure that everything gets seated correctly. I'm then going to come back and add 1 clamp diagonally across the seat. And the purpose of that clamp is to make sure I am gluing things up square and that small area of reveal between the seat and the side rail is equal distant the entire length. Those clamps will then stay on for 24 hours. Underneath our seat, we have an area for storage, and inside here we have seat support cleats to add additional strength to the seat when someone is sitting on it. We have our storage bottom, and underneath the bottom we have storage cleats. Those are hidden from view. Those are the pieces that the bottom is sitting on. The dimensions of my storage cleat on the left side and the right side is 3/4 of an inch by 3/4 of an inch by 14 1/4 inches long. The front and the rear cleats are 3/4 by 3/4 with a length of 45 inches. I found some offcut pieces from previous boards. I should be able to get my 2 shorter left and right storage cleat pieces from my smaller stock and my 2 longer 45-inch pieces from my longer piece of stock. My objective is to create 4 storage cleat pieces, each measuring 3/4 of an inch by 3/4 of an inch, and I have a couple different lengths. I have 2 individual pieces and 1 larger piece that I need to split and get 2 pieces out of. I'm going to begin by ripping my pieces to 15/16 of an inch. Now I do already have 1 pretty good edge. I am not worried about the mill marks at this point. I just need a good edge to put up against the fence. Those 4 pieces will then be run through the planer, alternating sides until I can bring them down to 3/4 of an inch by 3/4 of an inch. And I can then cut each of those to length. And that leaves me with 4 pieces, all of which are 3/4 of an inch by 3/4 of an inch. 2 of them have a length of 14 1/4, and the other 2 have a length of 45 inches. After gluing up my various assemblies, my project has sat for 24 hours. I'm going to install a couple clamps on the back leg to help hold the seat up. And then I'm going to add some additional ones on the armrests. And my objective is that I don't want it to fall on me while I'm working on the storage area. And with our longer cleat piece, we will apply a little bit of glue and spread that around. Then we'll install it at the lowest point on our rear seat rail with a few clamps. And we want to continually verify that the bottom edge of that cleat piece is perfectly flush with the bottom edge of our rear rail. And then we can clean up any glue that's squeezed out. And then we'll tack that in place with 1 1/4 inch brad nails. Those clamps can then be removed. We can wipe the glue again and move on to the next piece. Now we are doing both of the long pieces first and then adding the short sides. And with that last one installed, this step is complete. With the storage cleats created and installed, we are ready to start thinking about the storage bottom. According to our parts list, the storage bottom is 1/4 inch oak veneer plywood. This measuring 15 3/4 by 45 inches. The 15 3/4 by 45, I'm going to wait on those measurements and double check on my project because I could be off a little bit. Now I will be pulling this from a partial sheet of plywood. This plywood is 1/4 of an inch thick. The sheet is 96 inches long, which will easily yield me my 45-inch length. I am currently 32 inches wide, which will easily yield me my 15 3/4. And I do want to verify those measurements. 45 1/32 by 45 1/32. Front to back, I am 15 7/8 by 15 7/8. So I am just 1/8 of an inch wider. I will keep that in mind when I size this down. And I also want to mention the grain pattern. It is most normal to have the longer measurement of 45 inches to go with our grain. So the grain length is our longer measurement. So I will make sure my 45 inches gets measured with the grain. I have previously determined that the length of my bottom needs to be 45 inches and the width of my bottom needs to be 15 7/8 inches. On the panel saw, I'm going to load my good side of the sheet facing the wall. This will give me a little cleaner cut. And we can measure, mark, and cut that piece to our length measurement. And we can then rip that to 15 7/8 on the table saw. And we can then test fit that in our project to see if our measuring was accurate. And this bottom piece fits very nice. With the bottom cut and dry fit Everything fits really nice. The only issue that I notice is that the distance on the ends is a little bit smaller than the distance in the middle. This has caused a very small gap, but if I squeeze the boards together, that gap closes. So when I install this, I will be putting a couple clamps underneath and very loosely tightening those down just to pull that in. This will be installed with a little bit of glue on the top edge of the cleat. The bottom is going to sit in there, and I'm going to add some weight to kind of hold this down, and then I'll add those couple clamps in the front. And with that bottom installed, we're going to let that dry for 24 hours. Our project has 2 seat support cleats, one on each side. This will add structural integrity to the seat when someone sits on it by helping prevent the seat from bending down when there is a lot of weight put on it. Although the plans call for our seat support cleat piece to be 3/4 by 2 3/4 by 15 3/4, we are going to verify these measurements with our actual project. Now when the seat closes, I am sitting on the inside of my side rails. My seat thickness is about 0.8 inches. Calculating this would take some time, or we could just measure the back rail distance from where the seat meets the top edge to the storage bottom. And we can verify that back measurement with the corresponding front measurement. And both of these measurements are just a hair under 2 7/8. Lengthwise, I am at about 15 7/8, and I'm still going to keep my 3/4 inch thick measurement. We can then progress through the process for squaring a board with the miter saw, the joiner, the table saw, back to the joiner, and then the planer. And these should fit snug but not tight. They will be pushed all the way up against the side rail, but if any part of it is not correct, we can make those adjustments at this point. And we can do that same test on the other side. To install these, we will first apply a little bit of glue, position it into place, and we're going to add a few clamps. And after doing the other side, we can let this sit for 24 hours. With everything installed and glued, and we've waited 24 hours for everything to dry, we can remove all the clamps. With the exception of sanding, the project build process is done. However, all of the edges of all of our pieces are extremely sharp. We want to bring these down ever so slightly because we want the bench to retain a square, boxy look, but we don't want a sharp edge that could cut someone or get chipped off over time. So I will begin by using a sanding block and break all of the edges slightly. I'll then come back with a piece of 80 grit sandpaper and work over those edges again using light pressure, and then I'll finish up with some 120 grit sandpaper. The edges are not sharp, they feel nice and smooth. I can feel that little microscopic round over, and I'm not worried about getting cut or that chipping off. And then any larger flat areas, I'm going to finish up with 120 grit sandpaper on the palm sander. This process will take quite a while because this is a pretty large project with a lot of surface area. And with everything sanded, the last thing to do is install two 3/8 inch oak buttons at the back of our project. This project is now complete and we are ready for stain and finish.